Imagine a flying monster weighing more than 11 million pounds, with a wingspan of more than 1,120 feet, capable of staying in the sky for more than 40 days without landing. In the 1970s, Lockheed began the development of the CL-1201, a flying military base that could carry thousands of soldiers, launch parasitic fighters, and be powered by a nuclear reactor. But this ambitious idea faced three serious problems: the safety of the nuclear reactor, ensuring autonomy for 800 people, and the gigantic size of the aircraft, which went beyond the technological capabilities of the time. Why did the United States fail to realize this idea, which was ahead of its time? And is it possible to build such an aircraft today? Let's find out. The 1960s, the Cold War. As the arms race peaked, the United States was actively looking for solutions to strengthen its global military presence. In 1969, Lockheed was tasked by the U.S. Air Force to create an aircraft so large it could carry several thousand soldiers, launch 22 air-to-air parasites, and fly without landing for a month or more. Although the new Boeing 747 was seen as an option for the Air Force, Lockheed was tasked with developing an even more ambitious aircraft. And Lockheed proposed creating a giant aircraft that could serve as not just a carrier, but a celestial base. The main idea was to make an aircraft carrier that does not depend on ground infrastructure at all. It just hangs in the air. It was important that even its maintenance would not require a return to the ground. All of this meant special challenges for the designers. However, Lockheed was one of the leaders of innovation in the aerospace industry, and this project was the reflection of its desire for a technological breakthrough. The company's best specialists are set to work. The project was led by engineers and designers who worked on advanced developments. The main department was Lockheed Advanced Developments Projects, better known as Skunkworks. It was headed by Clarence Kelly Johnson, the aeronautical engineering genius behind such legendary aircraft as the SR-71 Blackbird and the U-2. Known for his ability to make quick and effective decisions, Johnson developed his philosophy of minimizing bureaucracy, focusing on innovation, and maximizing trust in his team. The idea for the CL-1201 was based on maximizing the use of the latest technologies, including nuclear engines, huge structures made of lightweight material, and modularity for servicing equipment on board. Aerodynamic researchers worked to ensure that the huge wingspan did not become a problem for flight. Solutions included the use of composite materials and innovative approaches to aerodynamics. The greatest emphasis was placed on stability in flight, and no aircraft of this size has ever been tested in real-world conditions. The project was based on the aerodynamic studies of the previous CL-1170 model, but was significantly larger. The new aircraft had a wingspan of 1,120 feet, approximately 341 meters, and a length of 560 feet, approximately 171 meters. The internal volume of the fuselage was 2 million cubic feet. For comparison, the wingspan exceeded the height of the Chrysler Building in New York by almost 14 meters, and the height of the Statue of Liberty by 3.5 times. The cargo capacity of the aircraft was estimated at 10 to 20 million pounds, approximately 5,440 tons. This figure was chosen because Lockheed did not see the need to transport more cargo. Due to the enormous size of the aircraft, standard fuel could not power it, so it had to be equipped with a nuclear reactor capable of generating 1.83 gigawatts of energy. This is more powerful than one power unit at the Chernobyl nuclear power plant. Thanks to this system, the aircraft could stay in the air for up to 41 days without landing, maintaining a flight altitude of 16,000 feet and a cruising speed of Mach 0.8. The only reason for landing would be to replenish food and water supplies for the crew of 475 people, or up to 800 people during combat missions. As you can see, the CL-1201 was meant to be not just an airplane, but a real flying city. Wingspan, 1,120 feet 0 inches, 340 meters. Wing area, 125,204 square feet, 11,630 meters squared. Relative wing extension, 10. Gross weight, 11,850,000 pounds, 5,375 kilograms. Power plant, 4 times main, 182 times lift fans. Endurance, 41 days. Tactical fighters on board, AAC variant, 22. Reactor power, 1,830 megawatts. Some of this could have been realized more easily, but some of it was unheard of. The project had 3 main challenges that eventually became fatal for it. What were they? The first challenge was the safety of the energy source, i.e. the 1.83 gigawatt nuclear reactor. It had to be compact enough to be installed in an airplane and at the same time protected to avoid radiation leakage. The second challenge was autonomy. The 800 people on board had to be provided with living space, water, food, etc. The third challenge was size. It was obvious that the CL-1201 would be the largest airplane in history. How did the designers decide to meet these challenges? For example, any accident with a nuclear reactor threatened to cause radioactive contamination. Therefore, they decided to focus on an automatic emergency shutdown reactor, which had an automatic shutdown system in case of critical malfunctions. In the event of a disaster, the aircraft had to disconnect the reactor and burn it in the upper atmosphere to avoid contamination. We also worked on remote control. The plane could operate in unmanned mode if there were serious threats to the crew. Despite the fact that nuclear aviation concepts were actively developed in the 1960s, including the NEPA, Nuclear Energy for the Propulsion of Aircraft, and ANP, Aircraft Nuclear Propulsion programs in the United States, none of the reactors could become a practical solution for use in aviation. The reactors that existed at the time were too heavy to be installed in an airplane, even one as large as the CL-1201. A compact reactor with a high power output, 1.83 gigawatts for the CL-1201, was technically impossible. Ensuring the safety of the crew would require a multi-layer radiation protection system. Such protection significantly increased the weight of the structure, which was unacceptable for aviation. Reactors required sophisticated cooling systems that were difficult to integrate into the aircraft design. The CL-1201 was planned to use a liquid metal coolant, but this technology was at the research stage and could not be implemented in practice. Of course, there were more or less successful experiments of nuclear reactors that were tested on the ground. For example, the HTRE-3 reactor was used for experiments with heat generation that could hypothetically power engines. Even the Convair NB-36H airplane was converted to test crew protective systems against radiation. But it used a nuclear reactor only for experiments, not to power engines. Thus, the nuclear reactor for the CL-1201 remained a theoretical element of the project, and its creation even today looks extremely difficult. Modern aviation is focused on the use of hydrogen as an alternative clean fuel, improving the efficiency of electric motors for small aircraft, and finding solutions for carbon-neutral jet fuel. Nuclear reactors are not even on the agenda. However, let's get back to the CL-1201. What was proposed to be done to ensure the autonomy of the superplane? Providing food, water, oxygen, and waste disposal for such a large crew for such a long period was extremely difficult. The closed-loop systems, water and air purification, that were planned to be used were still in their infancy. Such technologies were developed mainly in the space industry and required large-scale improvement. Providing 800 people with food for 41 days required either a huge supply of food or complex food processing and production systems that were technologically unrealistic. Perhaps it was possible to deliver resources by additional airplanes. Risky. Maneuvering aircraft around the giant CL-1201 would have been very dangerous because of its size. During the 41 days in the air, malfunctions could occur in the aircraft systems that would require repair or replacement. It was impossible to provide all the necessary resources and tools for full maintenance on an aircraft of this size. The lack of emergency landing capability for quick repairs made the concept too risky. But that's not all. A long stay of the crew in a confined space could have caused serious psychological problems, fatigue, stress, conflicts, and physical complications. Could these problems be solved today? Closed-loop technologies, as in space, improved automation, and remote control systems could theoretically solve some of these problems. However, even today, the concept of an autonomous airplane with a crew for 41 days seems too expensive and impractical. Now we come to the third challenge. Was the size of the airplane a real problem? Unfortunately, yes, because the dimensions created difficulties for design, construction, operation, and maintenance. For example, the wings of the CL-1201 had a span of 341 meters. Due to their size, the wings could bend or even collapse during flight. It was necessary to develop structures that could withstand these loads. To ensure the flight of such a giant, extremely high lift was needed, which required the development of new wing shapes and materials. With increasing size, drag also increases, which reduces flight efficiency and requires even more engine power. Then, there's the weight. In the 1960s, there were no materials light enough and strong enough to ensure the stability of a structure of this size. Moreover, a payload of more than 5,000 tons became a problem because it exceeded the weight capacity of even the largest airfields. The airplane needed an extremely long runway. Even modern airports are not able to accommodate such an aircraft. The enormous weight caused damage to conventional concrete strips, and their reinforcement would have required huge costs. And how to maintain it? Building giant hangars is not a problem. However, the airplane's components were so large that transporting them to the assembly site would have been a separate engineering challenge. Any breakdown of such an aircraft would require special equipment and personnel, making maintenance very expensive. No fewer concerns were raised about the CL-1201's stay in the sky. The huge aircraft would create strong vortices that could pose a danger to other aircraft flying nearby. Coordinating the movement of such an aircraft in the airspace would require radical changes in the air traffic control systems. Consequently, the size of the aircraft resulted in astronomical costs. Maintenance, personnel, and infrastructure costs would be disproportionately high compared to the benefits. Is it possible to solve this today? Modern materials, technologies, and management systems could partially solve some of these problems. The use of composite materials to reduce weight, the development of aerodynamically efficient shapes, and the use of automated systems to control the aircraft. However, even today, sizes similar to the CL-1201 remain very challenging and economically impractical. The gigantic size of the CL-1201 complicated every aspect of its design and operation. Problems with aerodynamics, infrastructure, logistics, and safety made this project more of an engineering experiment than a real airplane. Nevertheless, the designers did not give up hope and even created several versions of the airplane. The two known versions are CL-1201-11 and CL-1201-13. There is also a third mysterious model, the CL-1201-12, but all information about it has been deleted. The CL-1201-11 was called the aircraft carrier. It was supposed to carry 24 aircraft, 11 fighter bombers under each wing and 2 more in the fuselage. The documents mention the F-4 Phantom aircraft. This version was to serve as a command center during military operations. The CL-1201-13, known as the Logistics Support Aircraft, LSA, was supposed to carry 400 soldiers and 1,150 tons of cargo. It would have been accompanied by medium-sized Boeing 707 transport aircraft that would have delivered cargo and troops to airfields or landing zones. The development of the CL-1201 took up to 4 years in total. In 1968 to 1969, the project was at the stage of active modeling and design, and in the early 1970s, work on the CL-1201 was stopped. At that time, the concept remained on paper, as it became clear that its implementation was technically, economically, and politically impossible. Work on the project did not even move to the prototype phase. This means that the focus was on theoretical calculations, drawings, and technical models. In addition, Lockheed was engaged in several other strategic projects at the time, including the SR-71 Blackbird, which was of much greater practical value. And how much money was spent on the design and could have been spent on the actual mega aircraft itself? The exact cost was not made public, as the project remained at the concept stage and did not reach the stage of detailed financing or production. However, reasonable estimates can be made based on scale and complexity. In the 1960s, large-scale aviation projects cost billions of dollars. For the CL-1201, the cost of research and development could have been $2 to $5 billion, equivalent to today's $20 to $40 billion, due to the need for innovation in nuclear power, materials, and aerodynamics. The cost of producing one CL-1201 could have exceeded $1 billion in the 1960s. For comparison, a B-52 strategic bomber cost about $14 million at the time, but the CL-1201 would have been 10 times larger and more complex. Taking into account the modern equivalent, this is approximately $8 to $10 billion for one aircraft. This means that the costs of its development could not be justified by mass production. The project was finally closed and not even classified. Thus, the great dream of military and aircraft designers remained only a calculation on paper. However, in 1997, something happened that shocked people and made many believe that the megaship had been built. On March 13, 1997, thousands of people in the area of the American city of Phoenix, Arizona reported a huge triangular object with bright lights that moved silently over the city. The event gave rise to numerous conspiracy theories, including speculation about aliens or secret military projects. Some claim that the CL-1201 was built and launched in secret workshops. For a long time, strange versions multiplied one after another, but most likely, these were just signal lights dropped by military aircraft from Luke Air Force Base. Such lights are used for training and exercise for pilots. They fall slowly with parachutes, creating the appearance of hovering in the sky. That is, conspiracy theorists have no place here. After the closure of projects like the CL-1201, there were no more attempts to create similar nuclear aircraft due to significant risks, technical limitations, and the development of more practical alternatives. The CL-1201 was a revolutionary and ambitious project in its time, demonstrating the technical courage of the era. But today, its implementation is no longer feasible due to risks, economic inexpediency, and the development of safer and more efficient technologies. In the future, with the emergence of new materials or energy sources, such ideas may get a second life. But for now, they remain an engineering experiment in aviation history.